All right, we are on assignment number 20, which is kind of like our first round of review. It just says determine the convergence or divergence of the series using any appropriate test from this chapter. So all of our tests are in play. First one I see looks like it could be alternating series tests, so I always try that one first because it's nice and easy if it works. So this series is alternating. And if I take the limit as n approaches infinity of the absolute value of the terms, then I do get 0. And it's reasonable to say that the terms are decreasing because the n plus 1th term is less than the nth term. So yeah, I would say this converges by alternating series test. For 52, I know this is a harmonic series, right? Just with a constant of 100 out in front. So this would be a P series where P equals 1. So yeah, you could say diverges by, there's not really any work to show, diverges by P series test. Or this is a true harmonic series. It doesn't have any extra terms added to it. So you could say diverges by P series test, or you could say it's a divergent harmonic series. Either one is fine. Remember, our test is going to be multiple choice, so you'd just be looking for one of those two options. All right, 53. This is another P series because you can rewrite it so that you add these exponents together. So this is the series of 3 over n to the 1 plus 1/2 is 1.5 or 3 over 2. So this is a P series where P is 3 over 2. The rule is that P has to be greater than 1 for this to converge by P series test. So not all of these are long and drawn out. It's just a matter of remembering what the tests look like. On 54, this is geometric, but we need to check, remember, if this is geometric, because it's just a number to the n. We're checking to see is r, the absolute value of r, less than 1. So for that, we need to know what, excuse me, what 2 pi is approximately equal to. So remember, pi is 3.14-ish, 2 pi is 6.28-ish, but the point is that that is greater than 1. So I could say that this diverges because the terms are just going to keep growing. So this diverges by geometric series test, or you could also apply the nth term test and just say that, yeah, we know that a base number bigger than 1 raised to an exponent is just going to keep growing. So we will continue to add value to that sum. So you could say diverges by geometric series test, or you could say nth term test. So, so a lot of these, you could maybe apply more than one test. And again, for multiple choice, they're not going to have both of those as choices. It's not that one is more correct than the other. So you would just be looking for the one that they offer in there. It wouldn't be diverges by integral test or comparison test or anything like that. Okay, for 55, speaking of the nth term test, remember you should always mentally be doing an nth term test, which really just means, is this bottom heavy? If it is, then I can go ahead and do another test. But this is not bottom heavy. So I would just show that the limit as n approaches infinity of the terms, 5n over 2n minus 1, or just the sequence, that's just equal to 5 over 2. And the rule is that that's not 0. So if the terms are not approaching 0, then this diverges by the nth term test. Okay. All right, what about 56? This is bottom heavy, so I'm not going to nth term test. I have two options for this one. I would choose a comparison test, but I could also do an integral test. So I'm just going to show you both ways because, again, just because I always choose a comparison test doesn't mean in multiple choice they might use the integral test. So it's nice to know when you can use that. So let's do comparison first. I'm using a comparison test because this kind of looks like it could be a P series if it just didn't have these extra terms. So I can compare it to just n over 2n squared. I know that the first fraction is less. And when I'm making that comparison, I'm going to simplify this when I do the known series. So n over 2n squared is the same as 1 over 2n. All right, so I do have a known series related to 1 over 2n. So I know the series from 1 to infinity of 1 over 2n is a divergent harmonic series or divergent p series, whatever. And because the series or the terms that are on top are diverging, that doesn't tell me anything about the ones that are decreasing faster. So we have to do LCT to figure out if these two things act together or not. So the limit as n approaches infinity of the unknown divided by the known, or times the reciprocal of the known. This is 2n squared over 2n squared, so that's a tie. So you get 1. And remember, limit comparison test is, okay, if I get anything between 1 and infinity, or between 0 and infinity, then I'm good, and these two things act together. So because the harmonic series I know about diverges, this series diverges by limit comparison test. Now, this might be one where in the multiple choices, they have choices that say diverges by direct comparison test and limit comparison test. And so then you need to know that direct doesn't apply. That's why we set up the comparison. That's why we always act like we're going to do direct. And then we do limit if that doesn't work out. I said I was going to do this one with integral test as well. So I just want to remind you of that. So what if I don't see LCT in my choices? It's because they probably did integral test. Because we could have an f of x that's equal to x over 2x squared plus 1. Integral test would apply because for x greater than or equal to 1, f is positive. These would be positive numbers, decreasing because it's bottom heavy, and continuous, no vertical asymptotes on that interval. So I'm going to do this kind of, well, no, I'll do it formally, sorry. So I'm going to set up the limit as b approaches infinity of the integral from 1 to b of x over 2x squared plus 1 dx. So the reason we could also use integral test here is because u sub will work out nicely. If we let u equal to x squared plus 1, then du dx is 4x. Solve that for dx. Sub that in for dx, du over 4x. So this whole thing is u. This x cancels with this one. There's a 1/4 left. So let's rewrite what we have. So we have the limit as b approaches infinity of 1/4 times the integral from 1 to b of just 1 over u du. And what is that equal to? So let's get our antiderivative here. The antiderivative of 1 over u is ln of u. Let's put u back in there, 2x squared plus 1. Evaluated from 1 to b. And let me just keep going with my slightly irritating having to keep all this limit notation. It's annoying to do this, but if you just do it, then you're practiced with it and you won't. If you get lazy about doing this in your homework, you're probably not going to do it correctly on a free response. So it's just one of those things you just kind of have to power through. Finally, I can take the limit. So this is 1/4. The natural log, of infinity is infinity. Natural log of 3 is a constant, but subtracting a constant from infinity doesn't matter. So overall, this is infinity. So because the integral converges, it means that the series would also converge by integral test. All right, so you could have either. They come to the same conclusion. That's the reason sometimes you can use different tests. If you're using different tests, they should agree and come to the same conclusion. All right, let's look at 57. Will alternating series work for this one? Let's see. It's definitely alternating. But then we have this weird thing going on. So let's see. This is the limit as n approaches infinity of, let's split this up. This is 3 to the n times 3 to the negative 2 over 2 to the n. So really, 3 to the negative 2 is 1/9. And then it's times 3 over 2 to the n. So this is this is a value, the base number is greater than 1, greater than or equal to 1. So these terms are not approaching 0. They're approaching infinity. They're going to keep getting larger. So I cannot use alternating series test. And instead, what that's telling me is that I already kind of have the work for it. This diverges by nth term test. Or you could say this could also have been a geometric series where your r was negative 3 over 2 to the n, and you still multiplied by 1/9. So it still would come out with diverges, but you could also say geotest. All right, let's take a look at, hold on, my color coding's off. That's going to bother me. I like to alternate so it doesn't run together. Okay, so now I'm ready for this one. So this is nice and easy. We're back to a p series. Square root of n to the third means you have a power of n to the 3 halves. 3 halves is greater than 1. So this converges by p series test. We love those. P series, geometric series, those are the easy ones. All right. Look at 59. You have a linear over like an n times a 2 to the n. When I see multiple n's all over the place, instead of picking a comparison test, like when I have two different types of functions, I have a linear and an exponential and whatever, this is where I might also want to just use ratio test. It has sort of a geometric piece to it, a 2 to the n, but I'm just not sure. Is it acting geometrically or not? So let's do ratio test. The limit as n approaches infinity. Sorry, side note, because what would I compare it to? I don't, I could cut off the plus 3, but I don't know anything about the series. Like this is not a known series right here. So so I would say ratio test. So we're plugging in the n plus 1th term. Remember to use parentheses when you're doing that. Dividing by the nth term, which means multiplying by the reciprocal of the nth term. And trying to see what cancels out. So there's not a ton of stuff that cancels, but 2 to the n plus 1 is 2 to the n times 2. So this 2 to the n will cancel with this 2 to the n. So there is still a 2 left. And then I can't really cancel anything else because I don't have the exact same terms. So let's just look at just a cleaner version of what we have. So I'm going to distribute here and combine a bit. So this is 10n plus 10 plus 3, so plus 13, times n. Don't forget about that little n up there. Down here we have n plus 1 times 2 times 10n plus 3. Show proper parentheses and all of that. Do not bother distributing anything together. You're just trying to think, if I did distribute, what would the highest power be here? I'd have 10 n squared, and down here I would have 20 n squared. So what is this limit? The horizontal asymptote would be 10 over 20, or 1/2. And 1/2 is less than 1. So this is acting like a convergent geometric. So this converges by ratio test. It's easy to lose track. I almost lost track of my 2 down there, which would have changed my answer. I would have gotten 1, and that's inconclusive. So just take the time to make sure you can read your writing and be careful about that. All right. 2 to the n over 4n squared. Now this is an exponential over a quadratic. Exponentials win the function races, right? So the top is going to grow a lot faster than the bottom in the end. So these terms are not approaching 0. So I can just show a quick nth term test on this one. The limit as n approaches infinity of 2 to the n over 4n squared minus 1 is equal to infinity. So this diverges by the nth term test. And with all of these, by the way, except for factorials, because we don't have a derivative rule for factorials, you could prove this by doing a couple of rounds of L'Hopital's method until this quadratic gets down to a constant. I'm not going to. You don't have to for these, but I'm just saying. Because, again, we have all multiple choice problems for this section of the test. All right, so for this one, cosine of n over 3 to the n. So remember, the cosine graph stays between 1 and -1. It just keeps fluctuating, right? So this, as we go through, will cycle between values from -1 to 1. So I want to do a comparison test. Cosine n over 3 to the n. I just want to compare it to 1 over 3 to the n, because sometimes it will be equivalent to 1 over 3 to the n, but any other time that cosine n is not equal to 1, it'll be less than or equal to, because it'll either be negative, which is less than a positive, or it'll be like some decimal on top compared to 1 over 3 to the n. So that's my comparison. I do know about this series from 1 to infinity of 1 over 3 to the n, or you can make that 1/3 to the n. That's a convergent geometric series. And because the series on top is converging, the one that's growing even faster than it, the one that's below, is also converging. So this converges by direct comparison test. Now, I believe if we did limit comparison test, it would also converge. So if I see both choices in multiple choice, I can't remember if this happens or not, but if I see both options, converges by DCT or converges by LCT, if DCT works, that's the one you choose. Like if it applies, which it does in this scenario, that's the one you choose. Okay, this looks alternating, so I always try that. Anytime I see -1 to the n, I try alternating, because even if alternating doesn't work in the second step, then I haven't wasted too much time. What is the limit as n approaches infinity of 1 over n ln n? Definitely bottom heavy, so it's 0. And it's reasonable to say that 1 over n plus 1 ln n plus 1 is a smaller fraction than 1 over n ln n. You're going to get larger numbers in the first denominator, so a smaller fraction overall. So this passes the ACT, which means, or AST, which means converges by alternating series test, not the ACT, the AST. All right, I see a factorial and it's muddled with some exponentials and whatnot, so this is a ratio test. If you're not sure what to do, oh wait, why am I writing ratio? If you're not sure what to do and you see multiple n's in multiple places, just try the ratio test. So ratio test is the limit as n approaches infinity of the absolute value of the n plus 1th term. So plug n plus 1 into everything. Divided by the nth term, which is multiplied by the reciprocal of the nth term. I just realized as I was going through this, I'm going to cancel a bunch of stuff here, but I could have reduced right here. n factorial is n times n minus 1 times n minus 2, until you get down to like times 1. So I could cancel an n here and make this n minus 1 factorial, but I didn't. So I'll just have more stuff to cancel here. So let me expand this out. N as n approaches infinity. Let me expand this out so I'm not just like slashing through a bunch of things. So here's an n plus 1. Let's make this 7 to the n times 7 times n factorial. What about n plus 1 factorial? That's n plus 1 times n factorial. And then we also have a times n times 7 to the n. All right, so what cancels out? 7 to the n cancels. N factorial cancels. N plus 1 cancels. So really, I'm left with just 7 over n. This limit comes out to 0. 0 is less than 1. So this converges by the ratio test. So this is kind of an interesting one, I think. We know that factorials win the function races, but even when you're comparing it to an exponential with a pretty large base times a linear, it still won out in that scenario. I don't know if it'll always win out. What if the base was 1 million to the n? Would the factorial still grow faster? I don't know. It's not something I have time to do right now, so we'll investigate that later. Let's see. ln n over n squared. Now, if I try to do a comparison test, which is what I first thought of, I was like, oh, okay, I'm going to compare ln n over n squared to just 1 over n squared. And remember, ln of n is a growing function, so it is going to be larger than 1 over n squared. So I do know about the 1 over n squared sequence and its summation here. That is a convergent p-series. So everything's going just fine so far. DCT does not apply because the series on the bottom is converging. So that doesn't tell me anything about the one that's growing, decreasing more slowly. I keep saying growing. That just means I need to do limit comparison test. And so I take the limit as n approaches infinity of my unknown, which is this, over my known, or times the reciprocal of my known. Now here's where I get a problem. The n squareds cancel. The natural log of infinity is infinity. And remember, the rule for the comparison tests is, let me go back to our comparison tests, actually. Let me show you where this is in our notes. Where'd it go? Here we go. What if you get infinity when you do this? Well, you can only say that your unknown diverges if the known diverges. But our known does not diverge. Take a look at our known one. Our known converges. So this is inconclusive. Kind of tricky. I don't run into this very often. And we might be tempted to say, oh, I didn't get a limit, so whatever, I'm trying, these don't act together. It gets kind of confusing. So it's not diverges by comparison test or limit comparison test. What else can we do? I suppose you could maybe try a ratio test. I didn't try that. My next thought when one of these fails is to say, can I do it with integral test? Because integral test should usually work provided the conditions are satisfied. It's just, do we know how to integrate that? So, all right, so let's look at integral test then. So integral test would be f of x is equal to ln x over x squared. For x greater than or equal to 1, these terms are positive because, well, let's see. Yeah, that's right. Because when I plug in 1, that's where ln of 1 is 0. Sorry. And then all the terms after that are positive. Okay, anyway, f is positive, decreasing because a quadratic grows faster than a natural log, and continuous because there's only a vertical asymptote for natural log at 0. So I am allowed to do the integral test. So let's get this set up. Now, ln of x over x squared. If this were ln of x over x, I could do u sub. But u sub is not going to work here because du dx is only 1 over x. So when I solve this for dx, I'm not going to get the x squared to cancel out. I would still have an x left. So it's not u sub. If it's not u sub, what else do we do with a natural log integral? Our only other option is integration by parts. Okay, so integration by parts. That's where we use our tabular method. And we're using Lyautey, so u has to be ln x. dv, it's not x squared, it's 1 over x squared, because remember, this is for a product when you have a product in your integrand. And when u is the natural log, then we're only going to do one round of derivatives. So the derivative of natural log x is 1 over x. The integral of x to the negative 2 is x to the negative 3 over negative 3. Or negative 1 over 3x. No, wait, what am I saying? Add 1. It's x to the negative 1 over negative 1. All right, so then what do I get for this? So I get plus, minus, cross your diagonal, loop around. This is going to be minus negative 1 over x squared. All right, so let's look at what we have when we start setting up this integral. So there's still a limit as b approaches infinity of, this first part is not in an integral, it's just negative ln x over x. That gets evaluated from 1 to b. And then minus negative, so I'm going to write plus, limit as b approaches infinity of, this one's still an integral, 1 to b of just 1 over x squared dx. which we can integrate. I'm going to go ahead and, well, no, I'm not. I have to do this all in one step, so I'm not going to plug anything in yet, do fundamental theorem there. Let's just get this all kind of squared away. So what did we say the 1 over x squared integral was? It was negative 1 over x. Now let's plug in our b and our 1. This is doing fundamental theorem. Negative ln b over b minus negative ln 1 over 1. I guess I could merge these limits together. They're the same thing. Negative 1 over b minus negative 1 over 1. All right, so again, I could do a quick round of L'Hopital's on this, but it's not required. Function races, the linear wins out over the natural log. So the bottom is growing faster than the top. So this is 0. And this natural log of 1 is also 0. Negative 1 over infinity is 0. And 1 over 1 is 1. So all of that is to say, okay, the integral converges. So that means that the series converges as well. Integral converges to 1, but the series doesn't converge to 1. We just know it converges. So that was probably our hardest one. Converges by integral test. Now, if I'm doing a multiple choice question, am I writing out all the limit notation? Not necessarily, but you do need to do a lot of these steps carefully. Maybe you don't have the limits on them, but you need to remember that b is infinity. All right, hopefully the next one's a bit shorter. Let's see. I see a factorial and an exponential, so let's do ratio test. And when you're doing ratio test, remember the ratio test is an absolute value, so that means we get to ignore this. Or could I have done alternating series test? Yeah, you know what? I guess I could do alternating series. I don't remember what I did on the key that I posted, but let's do that first. Alternating, check. Ratio test would also work, by the way. But alternating, check. This is definitely bottom heavy, right? The limit as n approaches infinity of, let's do the same thing we did with the one similar to this. I'm going to make this 3 to the n on top. I'm sending the 3 to the negative first, just down here, 3 to the first, times n factorial. 3 times n factorial definitely is growing faster than 3 to the n. That's 0, and it's reasonable to say that 3 to the n plus 1 over 3 times n plus 1 factorial would be less than 3 to the n over 3 n factorial. Because 3 to the n plus 1, that 3 to the first will cancel with that one. So you really are comparing 3 to the n. You're comparing it to n plus 1 factorial versus n factorial times just an extra 3. Anyway, converges. I'm over-explaining, I think. Converges by alternating series test. All right, now what about this one? This one has alternating, and this is kind of similar. Didn't we see something very similar to this? Where did it go? Yeah, like right here, this 3 to the n over 2 to the n, number 57. So this is kind of like that. It is alternating, but I don't know if we can say confidently that without doing L'Hopital's that 3 to the n over n times 2 to the n is necessarily 0. So maybe I would do a ratio test on this one. Sorry, colors again. Make that blue so I can continue to alternate. This one needs to be red. Okay. If you're doing the ratio test, this is what I started to say on the other one. Because it's an absolute value, you get to ignore the negative part. So you're just putting a 3 to the n plus 1 up here, n plus 1 down here, 2 to the n plus 1. Multiply by n, 2 to the n over 3 to the n. All right, so what's going to cancel? 3 to the n will cancel with a 3 to the n, and you'll be left with 3. 2 to the n will cancel with 2 to the n plus 1. You'll be left with 2. The n's can't cancel anything. They're just going to be there. So to rewrite this, just to make it a little cleaner looking, I've got a 3 and an n on top, and I've got a 2 times the quantity n plus 1 on the bottom. That's a tie, and I get 3 over 2. 3 over 2 is greater than 1. So this diverges by the ratio test because it's acting like a geometric series with an R greater, a common ratio greater than 1. All right, what about these last two? I think it's always a little different or kind of tricky at first to look at when they start showing us strings of numbers being multiplied. It's important to note that this is not n 2n plus 1 factorial. 2n plus 1 factorial, plug a number in for n. Say you plug in 5. That becomes 11 factorial, and that becomes 11 times 10 times 9 times 8. So 2n plus 1 factorial would be 2n plus 1, 2n, 2n minus 1, 2n minus 2. It would not skip the even numbers. It would not only give you odd numbers. So, okay, so that's the first thing. The second thing to figure out is, what is this pattern? We have this exponential on top, and this is not really an exponential on the bottom, but I'm not sure if we can just say nth term test and call it a day. They're sort of leading us into a ratio test anytime they show us things being multiplied. All right, so let's do ratio test. Again, ratio test is an absolute value, so we ignore the negative there. So you'll have 3 to the n plus 1. And then when you plug n plus 1 into this, you're going to get 2 times n plus 1 plus 1. You're plugging into the n there. So that's going to be 2n plus 3. All right, and then what's happening with that? You're doing odds. So the next one wouldn't be 2n plus 2. It would be like 2n plus 1. Because that's going to give you an odd number too, right? If you double a number, you make it even. If you add an odd value to it, it will become odd, okay? So let me just do one more. So then the next one would be like 2n minus 1, dot, 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 until you get all the way down to 7 times 5 times 3. That's where it stops. So whatever n you're plugging in, if it's 100, you'll multiply all the odds. Well, yeah, if it's 100, you'll multiply all the odds from 203 all the way down until you get to 3. We're multiplying that by the nth term, which is 2n plus 1. There'd be a 2n minus 1, dot, 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 and then it says times 7 times 5 times 3. I threw in an extra term just to show stuff that's going to cancel. And then what about down here? We would just have a 3 to the n. Okay, so canceling things, the 2n plus 1 will cancel with the 2n plus 1, 2n minus 1 with that. All the numbers that get all the odd numbers that get multiplied after that will also cancel out. The 3 to the n will cancel with the 3 to the n plus 1 and leave you with 3 to the first. And this is still here. We have a survivor. So we really are just taking the limit of 3. Let me rewrite that. The limit as n approaches infinity of 3 over 2n plus 3. And that's bottom heavy. That's 0, which is less than 1. So this converges by ratio test. Let's try ratio test again on this one then. So my work got kind of stretched out there. Let me see if I can scooch this over a little bit. There we go. All right. So for 68, I'll just do this one in green so it's not separate. Same idea. This definitely looks bottom heavy, but when there are so many n's involved, I think that they don't want us to just say nth term test and call it a day. Again, you could be searching in multiple choice questions for the right answer. They're probably going to say ratio test. So let's apply the ratio test just to see what it looks like. I almost always use ratio test when I'm just multiplying stuff like this together. So the top would be 3 times 5 times 7, dot, 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 dot. And then if we're plugging, again, n plus 1 into this, it's going to be, there'd be a 2n plus 1, but that's going to also knock you up to 2n plus 3. And then down here, we would have 18 to the n plus 1 times plug n plus 1 into this. 2n plus 2 minus 1 is 2n plus 1. N factorial becomes n plus 1 factorial times the nth term, which is just writing down the reciprocal of the fraction that you see in the sequence. All right. What cancels? Let's look at some obvious ones. 3, 5, 7, and all those numbers cancel. This 2n plus 1 can either cancel with this one or down here with this one, but not both. Remember, n plus 1 factorial is n. Oops, my pen stopped working. Hold on. It's n plus 1 times n factorial. So this n factorial can cancel with this one. 18 to the n can cancel with 18 to the n plus 1. You've got an 18 down there. And because the rest of these expressions are not the exact same thing, none of them will cancel. But we can look at what we have lumped together. So the limit as n approaches infinity of, so there's a 2n plus 3. There's a 2n minus 1. And that's all that I see that's left in the numerator. In the denominator, there's an 18 times n plus 1 times 2n plus 1. What's that going to come out to? It's going to come out to, this is 4n squared plus some other stuff over 18 times n times 2n, 36n squared plus some other stuff. So this comes out to 1/9, and 1/9 is less than 1. So this converges by ratio test. All right, that finishes this first review. So that was pretty intensive. And again, what we're going to look at next, this helps you study what the different types look like, what the different tests, like what the series look like. What we're doing next is looking at like, well, what kinds of multiple choice questions are they going to ask us? So that's in our next review.